Just want to show you another perspective from the silicon providers and what needs to maybe to be done, but or at least to be improved. I wanted to call my presentation symbiotic hardware and software, but we're not there yet, and I will show you why a bit. So some words about Freescale, for who doesn't know. It's a global leader of embedded processing solutions, where we are providing definitely this embedded processing from 8-bit to 64-bit, multi-core, multiple GPUs and DSPs for markets like automotive, infotainment, industrial type of market as well, networking, and of course, consumer as well. This embedded processing is supported by a platform with software to provide complete solution. And of course, this solution cannot be complete without this control part, which is this analog power management type of products. The connectivity means this wireless interface, and the sensors, of course. It's one of my biggest interests so far. Three trends which are shaping our future, but also shaping the strategies of Freescale. The one and the big one is a connected intelligence. It's what we call intelligent. Why? And because we're all connected, more or less. We need data everywhere, anytime, but we need the right data at the right time. So it's why we need to put intelligence into this connectivity. Going green is definitely more about what we can do in energy efficiency and the power management to decrease the power consumptions of car, of portable devices, and others. Health and safety, it's over two areas where we are definitely involving. Health in health monitoring, and I will show you something on this one. And safety is where we move from passive safety in a car, for instance, to proactive safety. So that's just to give you more, we say, understanding of what we're aiming to. So the challenges we all see in a daily life, I will go skip to huge and permanent data flow. This is given, you know this better than me. The high workload is more than a real-time workload that we need to get a lot of data. But where I want really to focus more in is what we call this contextual interaction. And on this aspect is what is the specific applications which are needed where we are, when we want, and the way we want it as well. So this needs to understand the context we are in as well. The density of control is something we need also to we say, tackle as a challenge. We have a lot of different type of devices to control the time, the stress, the schedule, the agenda. And instead of being the slave of the technology, we should use the technology in order to better control all these kind of elements as well. So it's what we call this intelligent contextual interaction. And I will show you what are the components of this one. The first one, this is pretty obvious, is the positioning. We need to know where you are and where we are. To know the positioning, we need to combine all these kind of technologies. It's not exhaustive. The GPS, cell ID, Wi-Fi positioning, localization, accelerometer, e-compass, gyroscope, altimeter, and more to come as well. We need to have this full sensor fusion, and this needs to be combined in an efficient way to have maybe few meters type of accuracy indoor. What we need as well is to work more on the context awareness, and it's, I believe, where we will see more and more innovation and more, we say, application there, is about environment. Knowing where we are is good, but knowing what is our environment is even better. So we need also to understand the motivation of people, our motivation, our cognition, our moods as well, the goals, the status, what we are doing as well. To do this, we need to analyze movement, vibration, stress in terms of behavior, the gesture analysis. We need also to understand the noise in terms of, I would say, surrounding noise, but also emotion sensing. All of this needs aggregation of sensors, computing, and all these technologies are more or less available today. The next, I would say, pillar of this intelligent contextual interaction is, of course, this intelligent interaction. And it means that we need to gather all this data, to aggregate them, and in order to process them and to control them in an intelligent way in order to influence our environment. We want to control our social network, we want to control our friend, we want to control our time, we want to control our life. So to be empowered on that, we need to have some kind of assistant, we can aggregate a lot of this data and respond in an intelligent way. So to do that, we need GPUs, CPUs, sensor, high level of sensor fusion, data aggregation, and what I call a symbiotic software and hardware, which is, I would say, holy grail for a very efficient applications. So where is augmented reality? In fact, augmented reality, I see and we see this as a, I would say, high-level kind of technology which encompass all of this intelligent contextual interaction in order for people to get access to this. Without augmented reality, most of the application I'm going to show you will not be possible. And this needs to be done in an intuitive way and very seamlessly. I have a nice video. I don't know if I have time, but if I have time, I will show it to you. But it's a concept video. But this video is really summing up our vision about AR and where we see AR from our customers and for the market we are really addressing. Of course, automotive is one of the key ones. It's where we are a leader in infotainment. With head-up display is a perfect way to show more data for the drivers. So we see definitely a key role of AR in this area. Navigation, this is given, I would say. The one which needs to be really improved is location-based services. We know that we say the localization, we know your position, we know the service, we can be good to you, but if we have no way to display this in a very smart way and intuitive way, I don't think location-based services can really take off. So AR has a big role to play there as well. Gaming, I love the, like Thomas, Sony games, and gaming is definitely one of the areas where AR has a big role, but again, gaming will play a big role if it takes sensor information, contextual information, and Sony game again is a very good example. Healthcare monitoring, I will show you something on this one. We need to have an easy way to display some complex data from our healthcare. And AR is a key technology to enable new kind of services as well. No limit in displays. What I mean by that, it's, okay, Google is one thing, but it can be any kind of effective display to be used on AR. So what is Freescale doing in there, right? We are definitely providing complete platform for smart mobile device and portable devices, where we are providing application processors, power management, audio, but also all these kind of sensors like altimeter, barometers, e-compass, magnetometer, accelerometer, intelligent sensor hub, and we put this together in a platform which is ready for device manufacturer to be used for their development. Some highlight about sensors. Providing devices and MEMS and sensors is one thing, but we need to provide also the sensor fusion. Sensor fusion at device level puts more sensors in the same package, but also sensor fusion in software and how to use this sensor fusion. So we need to provide gestures and API. We have also built-in gesture within our sensors, like tap detection, like fall detection in our accelerometer. And we need to provide to some application, like pedometer, like e-compass, which can kind of fusion between between hardware and software, and operating system support. On this, again, I have some discussion earlier, but we need also to improve the way all these sensors are used and supported by operating system, because today, thanks to Apple, Google, and soon to Microsoft, we'll get more and more sensors. However, the way the drivers are defined are underutilizing the sensors. It's very difficult to get, we say, 90%, 10% of the performance are used of most of the sensors because of the limitation of these drivers. So today, for instance, we have an altimeter with a 30 centimeter accuracy, and we have also a way to minimize the processing and power consumption through intelligent sensor hub. We simplify also the sensor data utilization by providing complete type of solution there. So let me just skip to the next one, which is more on apps processor. This is the other part that Freescale is doing. We're definitely a clear leader in e-reader, in infotainment as well. And what we're launching this year is this complete family of quad-core, dual-core with multiple GPUs. And for software compatibility purpose as well. One example of how GPUs and, I would say, efficient software can be used within AR is using the SURF, which is the speed up robust features, which is heavily used for feature extraction. It's running in less than 100 milliseconds on our kind of GPUs compared to, we say, 2.4 gigahertz Intel chips, which is about 600 milliseconds. So just because it's really running on GPUs, which are extremely efficient for this kind of calculation, matrix calculation. The demo case, the virtual showroom I showed you yesterday, I have a 2 demo here for you to show you the difference between optimized software running on the dual core, on the single core, sorry, sub-gigahertz, and non-optimized software, which is even not usable at we say, user level for this kind of demonstration. So efficiency is extremely important for adoption of this AR interface. Some words about Home Health Hub is something we launched. We won a couple of awards. This is a complete platform to gather data of healthcare in terms of glucometer, ECG, and all kind of other data for elder people, for instance, wants to have an assisted living. And for that, we need to add an easy way to have more kind of services. One of them is how to use augmented reality to improve this medication type of taken. So they know when they need to take this medication, what is this medication, and at what time they need to take the next one. Without augmented reality, such kind of innovation and services is not possible. So you can even, it's not there yet, but you can imagine what can happen to this. It means that in real time, almost on a daily basis, we can monitor your healthcare information, get back to the system, and we can adapt your medication compared to your health improvement or not. So it's definitely a huge way to save money, to improve the way we are taking medication, but also this is the only way we see AR. I mean, say AR is the only way to get access to this information for elder people who are not adverse about technologies as well. So this is just to give you an highlight of what needs to be improved in terms of sensor fusion, efficiency in hardware. A few highlights of a new technology which can enhance AR, and it's open for discussion for sure. It's what we call this intelligent sensor platform for sensor fusion. It means that instead of having everything running an application processor, we mix up together sensors together with some dedicated microcontroller to do sensor fusion at sensor level. It means that this distributed type of processing is extremely efficient in terms of system power consumption. We can reduce the power consumption about 90%, since the right amount of processing is used for the, we say, kind of sensors which are running at a few hundred hertz in terms of data taking, compared to these guys, which are megahertz type of processing as well. So asymmetric processing is definitely a key technology of having efficient sensor data fusion for positioning and augmented reality, of course. And this can be encompassed in a complete distributed processing where we mix multiple CPU with multiple GPUs and distributed processing for sensor fusion. This kind of distributed processing is only efficient only because the software which is written for that heavily use hardware acceleration from GPUs, heavily use also this kind of asymmetric processing. So again, if the wrong software is using on the right platform, on the right hardware platform, is not going to work as well. So it's where we need to have hardware community and software community to work in a symbiotic way. And again, still a lot of work to do on this one. Another topic I wanted to highlight to you guys, because gaming is big. What we develop within Freescale and with some doctors, it's the way to catch emotion, to measure the emotion of people. And to do that, we use gaming, because gaming is definitely one of the best way to display different kind of emotion in a very short time. So we are just measuring the sweating, the attitude, the heartbeat rate, the muscle contraction, and muscle relaxation in order to gauge the user kind of emotion. And from there, we can definitely adapt the gaming. But beyond that, and with a bit of more sensors that we're using on the phone, you can imagine what can be done, like a special kind of Neopets with your phone, if we can get this emotion translated to your phone, or this emotion to your TV remote control, which can give you, we say, what you might want to watch tonight in your 100 channels and 100 movies you have at home, compared to your mood. So this is definitely another key area where I believe can enhance definitely AR, and where AR needs to play a big role as well. So to reach this kind of ideal world where we enter a shopping center brought by kind of AR display and an accurate localization, giving us what we are looking for, the people we want to meet as well, there's still some work to do in terms of efficiency, in terms of usability, and in terms of how to put this in a very efficient way, in a symbiotic way. The perspective, we see that AR definitely can be used to exemplify value content and enable new applications and services. Let's put it the other way. Without AR, I believe some services and some applications will not be even possible. However, we need to have efficient hardware solution working with efficient software as well. And this is combining on the hardware side, sensors, sensor fusion, CPUs and GPUs, but also it means that in the future, the developers can reuse this kind of optimized hardware with optimized software to create an innovative type of application and optimized one as well. On this, if you have any question.
So looks like we have a question there, and if you just don't mind playing your video, actually, so that way we
yeah, if you have time, no problem.
People ask questions, and then since it looks like he's kind of locked in the middle there, if you can just repeat his question, please, so that way the people streaming.
Yes, so the question is, how do you get the 30 centimeter accuracy on the alligator? Are you measuring the air pressure and fusing that with current weather data, or do you measure it from the
It's 30 centimeter is relative type of, is relative.
Oh, it's not absolute.
It's not absolute, it's relative. Yeah. Because of course, even though it's so sensitive, if you blow on it, the altitude is going to change.
So it's just relative.
It's just relative, yes, absolutely.
Hi, question. Actually, I was reading an email, listening at the same time, so I must have missed something. You were talking about surf and some of the algorithms you're accelerating.
Mm-hmm.
Could you go into how the acceleration works? Is it SIMD? Is it software? Is it fixed function? Or what other algorithms are you using? What are you accelerating?
Oh yeah, no, this for surf was used as a benchmark only to benchmark our hardware and to see how the GPU were, we say, performing. This is just a pure benchmark one. So we use surf because it's extensively used for feature extraction, but it's not something we are using internally. We are just providing the complete platform with CPU, GPUs.
CPU, got it.
And again, the surf I'm showing you is 100% accelerate on GPUs.
Any more questions? I guess everyone's mesmerized by your video.
Again, it's a video we launched about a year ago. Right? It's not something very new, but it's showing, I will say, explicitly what we believe is definitely our vision for AR and where it can really be useful and used.
Just a real quick question, and this isn't so much on technology, but just to get you and Thomas, since y'all develop essentially these types of experiences in a way. people looking through their devices, and then also for like the automotive, insurance companies are going to love you, right? What are your thoughts, kind of, as far as the way that you see people creating these experiences now, where it's very much. I mean, I bump into people in San Francisco all the time because they're looking down at their devices, and you kind of have to move around them. So I mean, I guess this is more on the developer, or not, well, the developer experience user type side. But I mean, what you're showing these in your concept videos, I'm just kind of curious as to your thoughts on.
Maybe just one more before Thomas. It's in some countries, of course, like I learned in California, you cannot even use your phone while you are driving. However, you can use a GPS, right? So it's definitely, I would say, might be a bit disruptive, but it's not worse than any kind of GPS you are just watching when you are driving. And on this one, so far, nothing is forbidden on this one. On other countries, you can even watch TV while you are driving as well, like in Korea. There's nothing forbidden there. So and there are not much accident, even maybe less than US. So it's just a matter of legal framework for sure.
First of all, we founded our own internal legal department, to answer your first part of the question. The second side of thing, it's a chicken and egg problem. If you don't have the accuracy to track the device, you end up with bigger overlays, right? If you think it through, you need to have bigger overlays to signal something, to point at something, because you have less accuracy. If you're getting better accuracy, you can make them smaller. For the automotive field, they have what they call the horizontal line, which is basically the middle of the windscreen, and everything which is below the horizontal line is very, very dangerous to cover the virtual object. But there are disciplines out there, UI designers, and all kinds of regulation taking care of that. For the more smartphone-driven community, it is a topic. User experience and user interface design in augmented reality is something which is widely discussed. And to be honest, the future is an honest statement. A lot of the applications, even the ones on top of our software, are sometimes not really optimized for a good user experience.
Just to add one more word on the automotive, so there's another key technology which needs to be implemented is a gaze tracking, right? This is already in this ADAS in kind of security to make sure that the driver is not falling asleep. But with a gaze tracking, you can also adapt the augmented reality overlaying and to make sure that it's not disturbing if you are focusing on the road as well. So it's definitely a lot of technology, but honestly, I don't think it's going to be an issue for a driver on my side.
Any other questions?
I have one here. Have you looked at any machine learning algorithms to do context-aware kind of learning?
So learning machine for context awareness? No, because the context is extremely complex. The environment we have five senses for sure, but the type of data we need really to gather, and it's very complex. The type of sensors is pretty complex. So just to gather all this data and try to have some machine learning, today we see this as a big hurdle and a lot of processing. And after, what do you do with all this data? So that's a key issue. If you have a solution, we'll be pretty, open on this one, and happy to see that. But today, I've not seen something which is usable for as a machine learning. However, if you know the pattern that you are looking for in, for example, the stress, right? You can definitely gauge the stress by using the pattern recognition from the accelerometer, for instance. If you know the user, of course. And on this one is more kind of pattern recognition style, which is using a specific algorithm rather than machine learning everything. So we need to have dedicated type of context awareness, I would say, machine.
Well, my question was more basically geared towards, are you looking at any hardware accelerators, things like that for that purpose, right?
Today we are having already some kind of acceleration because we have distributed processing at a sensor level where we have a specific microcontroller running software, for instance. We also want to use the GPUs because we have a couple of GPUs to do some acceleration, and there's a combination of CPUs as well because we have some dual or quad core. But there is no simple, I would say, common kind of common denominator between all these context awareness algorithms today to have a specific IP that we can hardware IP we can develop. But we might come to this one, I believe, in 2 or 3 years after more research.
Well, thank you again, Stephane.
Thank you.